Question 3, so if you take a question back, is talking about this thing. It's talking about a normal, okay? So far, we've been talking about tangents. So just remind me, what is a tangent?
It's a line sharing 1 point with the curve.
Good. So if I draw a line in like this, or a curve in like this, okay? My tangent, let's say at this point here, my tangent would look like this. You happy with that? Ish. It's not a great line. Let me try that again. Okay, my tangent will look like this. What's the relationship between a normal? What is a normal?
What?
What's a normal?
A normal line?
So if this is my tangent, what's a normal?
One sharing 2 points?
No, that's a secant.
Oh, normal sharing no points?
Normal still shares 1 point. Perfect. It's a perpendicular line to the tangent. Okay, so that would be my normal. Okay, so it's perpendicular to my tangent. Perpendicular to my tangent. The way which I think about this, imagine this curve is a roller coaster. Okay, so I'm traveling along this roller coaster. Okay, now what do normal people do if they're on a roller coaster? Put their hands up in the air, right? Well, okay, fine. They put their hands up in the air. Normal people put their hands up in the air. So if you imagine this is my roller coaster, okay? At this point here, normal people would have their hands up in the air. So which direction would they up in? They'd be facing in. They'd be going in this direction. Happy? Yeah? Whereas tangents are kind of like zombies, right? So think about zombies and normal people. Yeah, that's very well. Doesn't it? So, okay, so for question 3, in fact, we could probably quickly do this one. It gives you a curve. It's y equals 6x to the power of 5 minus 2. Okay, y equals 6x to the power of 5 minus 2. And it asks you to find the gradient of the normal at x equals 3. So at x equals 3. Negative 3. Okay, so how could I do this? I want to find the gradient of the normal this time.
Well, it's the same question, like find the point where the gradient of the normal line to the curve is...
No, it's a different question. So this is question 3. So this is question 4, and this is question 3. So I've just gone back a step because I've realised that this is in here.
What is it? Is it 93, 83?
Page 89, yeah.
89.
So this is question 3. It says find the gradient of the normal. Okay. So all the other questions on that page, all the questions before that on the page, are find the gradient of the tangent. This is find the gradient of the normal. So what am I going to do differently? Or am I going to do anything differently?
No.
Can you tell me?
We don't know.
Okay. Think about the relationship between normals and tangents. What's the relationship? They're perpendicular. So if I know the gradient of the tangent, I can find that. We've done that, right? We've done that hundreds of times. How could I find the gradient of the normal from the gradient of the tangent?
The two gradients have to get together.
Perfect. So the gradient of the tangent multiplied by the gradient of the normal should times together to make -1. Or you can think about this as the gradient of the normal should be -1 divided by the gradient of the tangent. So in other words, they're negative reciprocals of each other. So if we know the gradient of the tangent, it's really easy to find the gradient of the normal. So set it up in exactly the same way as before. We differentiate first. So what would this thing differentiated be?
30x
To the power of?
power 4.
4, good, and -2x to the power of 0 just becomes a constant, so it's 0. Okay, then I stick x equals -3 in there, so I say at x equals -3. My gradient, remember this is the gradient of the tangent so far. Okay, so my tangent line at x equals -3 is going to be equal to what?
So we just put the 3.
The -3 into here.
Yeah, so it's 2,430.
Good, so that's the gradient of my tangent. How can I use that to find the gradient of my normal?
Well, -1 over that.
Good. That's it. Okay? It's no more work. Absolutely no more work. If you can find the gradient of the tangent, you can find the gradient of the normal really easily.